Let's finish our 2.1 Day 2 lesson with the final application problem. At the top, I've rewritten the real-life application process. Remember to read the problem carefully, determine your variables. X, the input, is usually your time representation, and then Y can be whatever you're kind of comparing throughout time. Create at least 2 ordered pairs, and then use point-slope form to write your linear function. It says the population of Minneapolis was 382,688 in the year 2000 and rose to 415,622 in 2016. Write a linear function that gives population as a function of time. And look at our rounding rules. It says round to the nearest thousandth. You're probably going to want a calculator to follow along with this one. It says the population of Minneapolis in the year 2000 was 382,688. So this would be the x coordinate, and this would be the output in that year. And then in 2016, there's another x coordinate. The population rose to 415,622. I'm not quite sure why there's a space in there. Sorry about that. If we can represent 2 pieces of information as our 2 ordered pairs, we would have 2,000, 382,688, and I'm not going to put a comma in there just so that we don't have so many commas to work with. And then we have 2016 and 415,622. So now it's kind of business as usual. We have our x1, y1, and our x2, y2. If we're going to create a linear function, the first thing we're going to want to calculate is the slope. y2 minus y1 over x2 minus x1. I'd like you guys to type that in and round your answer to the nearest thousandth. Then press play and we'll move on and finish our equation. Did you get a slope of 2058.375? That's actually the exact slope. 32,934 divided by 16 rounded to the nearest thousandth is exactly 2058.375. The slope identifies the change in population each year. That would mean in Minneapolis, on average, the change in population increased by just over 2,000 people per year. To write the linear model, the second thing we'll then do is plug this into point-slope form. We'll do the y minus y1 equals m times m minus x minus x1. And if anybody noticed, I actually just recognized that I spelled Minneapolis incorrectly. There should be an O right there. Sorry about that. All right, let's plug in what we know. We have our x1 and our y1. We'll have y minus y1, which is a whopping 382,688, equals m, which is our really big slope, 2,058.375, times x minus x1, which is 2,000. Go ahead and distribute the slope in, move the 382,688 over, and write your final equation. This will model the population as a linear function of time. Once you think you have it, press play and we'll be done. As I distributed the slope in, I got 2,058.375x minus 4,116,750. I moved y1 over and got a linear model. Y equals 2,058.375x minus 3,734,062. This would model the population of Minneapolis as a function of time. And that ends our notes for 2.1 Day 2.